charging by induction illustrates an important topic in circuits, actually. Let's charge by induction with something large. We did it with two aluminum spheres that are about the same size. Let's think about doing it another way. What if we have our Teflon rod here, right? And let's have one of our aluminum spheres here. Okay. Well, we know what's going to happen to that single piece of metal. Electrons are going to run and hide over here, leaving that side kind of positive. We're going to polarize this thing. So this is our insulator that's charged, and this is our conductor that is now polarized. So rather than cut, what we really did is we had another aluminum sphere touching it. So we actually had this, they were touching, the electrons were actually over here, and we pulled it apart. Okay? But what if we did it with something large? What if instead of another aluminum sphere the same size, what if it touched a huge aluminum sphere like this? Would it help? Would it be any different? I don't know. You might actually get a little bit more charge on it, because now this can go away. It goes even further away. Maybe you leave more of the area charged. So you can kind of imagine it might be better to touch it to something large. So to see if you can do this with something larger, we need a large conductor. So let's think. This is the biggest aluminum sphere I have. I don't have any other big aluminum spheres on me at the moment, but I do have one other big conductor, and that's me. You are a conductor, not that conductor. You are a conductor in the terms of sort of a salt water, right? So if you have a solution of salt, the salt breaks down into sodium and chloride ions if it's table salt, and those ions can move around in the water. So you have mobile charges in salt water. So salt water is a conductor. Not as good as a metal, but it's still a conductor. So in terms of electrostatics, your body is basically a leaky bag of salt water. It's full of this salty sort of gel, your skin is moist, you're basically salt water. So you are a conductor. So what I can actually do is make myself the other conductor. So we charge up the rod, and I put my finger here, and then I bring the rod here, and you might worry that I'm making a circuit, but nothing flows along the rod, so it's okay. I just pull my finger away, and that charges up the rod. Let's see if it worked. So remember, that should have left the rod what? It should have left the rod positive, because we pushed the negative charge into me. So now this negatively charged tape should be attracted to it, and sure enough, it's a positively charged piece of aluminum. Everywhere you go, it's got positive charge on it. Fairly strong, actually. And the reason it's strong is because I'm big. I'm bigger than that other sphere. We can get a lot of charge. In fact, the way you usually do this is you don't sort of have to be touching it and break contact. Often if somebody's going to charge something by induction, it's almost like a parlor trick. You almost have to watch quickly to see them do it. So you bring this here and you just touch it like that, and now it's charged. Just with that brief touch, you picked up the negative charge that was pushed to this side. Let me try it one more time, because if I do it and get a little closer, you'll probably even hear the spark. You can hear the charge jumping into my finger. So we get a little close to the mic here. We're polarizing it, and I'm going to accept the charge. So maybe you heard that. And now it's going to be very highly charged. Like that, see? Really wants to touch it. So I'm large, I'm a big conductor, but there is yet one other big conductor that you always have access to. Almost always have access to. And that would be really large conductor, the Earth. Okay? Not to scale. If you go deep enough in the ground, it's sort of wet dirt, and wet dirt is a good conductor. It's sort of a liquidy, jelly thing full of ions. So if you touch things to the ground, you can discharge them. Or you can think of it this way, is current or charge will flow into the earth from something charged up. And when we get into circuits, you're going to know that the flow of charge is current. This is why circuits are always grounded. We say grounded, it actually really means something. The symbol That means ground in a circuit, which you know or you'll learn about, really means ground. It means eventually when you build a building, somewhere there's a rod that has been dug straight into the ground, really deep, and that's where all the circuits in the building eventually have to go. They also use the plumbing, so there's other ways to do it. But building code does require an actual ground rod for buildings. So that's why we say ground. We really do mean the earth. And it really, you can first understand it by charging by induction.